Hey everyone, welcome back and let's write some more neat code today. So today let's solve the problem remove duplicates from sorted array 2. So we're given an integer array nums that's sorted in non-decreasing order. That basically means that it's sorted in increasing order, but there could be duplicates. So they say non-decreasing just to be absolutely correct, but maybe an array that looks like this. The problem is that we might have a bunch of duplicates. As we can see here, we have 3 copies of 1, we have 2 copies of 2, and we have 2 copies of 3. But we are only allowed to have at most 2 copies of any value in this array. So we can have 2 2s, 2 3s, and 2 1s, but we can't have 3 1s. So we remove it. But how do we remove it? Because we could just pop from the middle of an array, but that's not very efficient. So instead, what we do is just shift the values. So what we would actually want to do in this case is remove this 2, but we'd also remove these 2 guys and move the 2 values over here. Same with these 2 3s. We'd want to remove them from their original positions and then push them over here where the next available slots are. So this is what our actual array would look like. Now, when we say remove from here, we're not actually deleting that memory or even overwriting the value in this position, but we consider it deleted. Our actual output array will look like this: 1 1 2 2 3 3 3. But we need some way to indicate that these are the only real values. Like this is taking up space, but don't consider this as an actual value. So what we do is return an integer indicating the size of this portion of the array, which this problem refers to as k. The convenient thing is that the way we're going to solve this problem, we're going to have a pointer. I think it's going to be called I, but it might be called something else. But at some point, that pointer is going to be all the way over here. And the way that indexes work, they start at 0, 1, 2, all the way up until 6 in this position. And look at that. The size of this array happens to be 6. So wherever we leave off at the end of the array is also going to be the length of this portion. So that's exactly what we can return, whatever value this pointer lies on. And it's possible that maybe we end up going out of bounds, like our I pointer over here is actually out of bounds. That's also going to work. So that's what we're looking to do. Now, how exactly can we solve it? That's the tricky part. I'll show you a valid way, but first let's go over the thought process. So let's take a look at a slightly different example. I basically just added another 2 over here. So now the values that we're going to remove is this and this. But if you try to solve this problem like the first version of this, remove duplicates from sorted array, what you would do is have 2 pointers. Let's call them a left pointer and a right pointer. Initially, they're going to both start here. And we're going to take the right pointer and increment it anytime we see a value. Like in this case, the right pointer, okay, we see 1, 1. Then the right pointer is over here, another 1. That's fine. We can have up to 2 of them. But now over here, we see a third one. So what we would do here is we'd say the left pointer is going to be incremented because we have a 1 here. We're allowed to have that. So we move the left pointer over here and we move the right pointer as well. The right pointer is going to tell us what value we're looking at. And I'll show you what the left pointer is going to tell us. Here we have another 1, but that's okay. We've only seen 2 so far. Because this array is sorted, all duplicates are going to be adjacent to each other, just like the first variation of this problem. But now we shift the right and left pointer again. Now over here, we see the third 1. That's not good. So what we're going to do at this point is not shift the left pointer. We're going to leave it here. What the left pointer tells us is that every value before this point is our array so far. Like this is our array so far with the duplicates removed. We've seen these 3 values, but we know this doesn't count. So this is our array so far, the first 2 values. That's why we're going to leave the left pointer here. And we also know that this is the spot next time we see a value, we're going to push this over here. And actually, that was the spot the entire time. When the left and right pointer started over here, and we saw that this is not a duplicate so far, what we would actually have done is taken the value at the right index and moved it to the left index. Now, in this case, it didn't really do anything because both of the pointers are over here. So we didn't swap anything. And here, we didn't swap anything when the left and right pointers are here. And over here, when the left and right pointers are here, we didn't swap anything, but we just left the left pointer over here. And now we're shifting the right pointer over here. Now we see that we have a 2 value. This is not a duplicate. So we're going to push it to the index over here. So we're going to overwrite the value here. We're going to put 2 over here. And now our left pointer from here is going to be shifted to be over here. And our right pointer, which was here, is now going to be shifted by 1 again over here. Now, this is kind of the problem with this approach, and I'll show you how to fix it in just a second. But now notice how there's 4 2s in our array. So over here, now we're going to say, well, this is only the second 2 we have seen so far, but how are we actually going to determine that? Like, how are we going to know if there are more than 2 copies of this value? The easiest way to do it would be to compare this value to the previous value and the previous value before that, which would tell us that this is the 3rd 2 in a row. So what we would say now is we're not going to take this value and move it to the left position. We're actually just going to skip this value, leaving our left pointer here and taking our right pointer now and incrementing it over here. But do you kind of see the problem with this approach? Now we're going to get to this 2, do the same thing. There are multiple copies of it consecutively. So we skip this one and we move our right pointer over here to the 3 over here. Now we see this 3 does not have duplicates. So we're going to move it to the position with our left pointer. But we're going to end up overwriting this guy. We need 2 2s. We're not allowed to have 3 of them consecutively, but we can have a couple in a row, but we're going to end up overwriting this one. So that's kind of a problem with this approach. The solution is actually really, really simple, especially when we're going to look at the code. But in terms of drawing it out, the main thing is just that when we get to a value, we're just going to count how many there are. Like, we're going to have a nested loop, which is going to bring our pointer over here, our right pointer, and I'm just going to keep counting how many of these 2s there are. And by the time we get to the end of it, let's say our left pointer is still over here, but by the time we get to the end of that streak, we counted 3 2s. So we only want 2 of them. So what we do is take the first 2 and then shift them over by 1. We move this one into the left position, so put the 2 over here, and then take our left pointer and shift it by 1 over here. Then we take this 2 and put it in the left position, and then we take our left pointer and once again shift it over here, but we've already added 2 2s over here, so now we're done. Then we take our right pointer, increment it just by 1 because we're at the end of this streak. Now we want to get to this streak. So just to clean this up a little bit, right pointer's over here. And now we do the same thing here. There's 2 of these. We're going to count them. Our right pointer is going to end over here. Yes, we have 2 of them. And we're going to start pushing both of these at the point where our left pointer starts. So we would put the 3 here and then put another 3 over here. And then our left pointer would be over here by the end of it. So I'm going to just draw that out. Our left pointer is here. And at this point, our right pointer would be incremented by 1 again. Now we're out of bounds. So we would return this value. If I didn't make it clear at the beginning, all we're returning is this integer value k, which in our case is going to be 0, 1, 2, 3, 4, 5, 6. 6 is going to be what we're returning because there are 6 values in this array. We're doing everything in place, so we don't have to worry about additional data structures. But as you can see, this is definitely the correct array with no more than 2 copies of a single value. And we did it in linear time. Even though we have nested loops, you can see the 2 pointers we had left and right, both of them are going to iterate through the entire array at most once. We're not, doing it a variable number of times. So the time complexity is going to be 2 times n, which we know reduces to b big O of n. There's no extra memory that we're using, so the memory complexity is constant. So now let's code this up. So I'm going to have a left and right pointer both initialized at the beginning of the array, and then just like in the drawing, I'm going to have a right pointer that will iterate through the entire length of the array. And then we want to count how long the current streak is. So what we're going to do is first set the count equal to 1, because whatever number we're at right now at index R is going to be a new number. And we want to compare it to the next value in the sequence. So nums at index R plus 1. While this is true, then we want to increment the right pointer. And for convenience, we'll increment the count as well. Having an extra variable for the count makes things a bit easier. But there's a couple catches with this. What if R plus 1 isn't even in bounds? Well, then we wouldn't be able to increment this. So let's add a guard here. While R plus 1 is less than the length of the array, and this is true, we're going to increment by 1. So now we have the count of this streak. It could have 2 values in it. It could have more than 2 values, like 3 or 4, or it might even just have a single value. It won't have less than that, but it might have a single value. We want to do at most 2 copies of this value. So what we do is take the minimum of 2 and the current count. So if the count is greater than 2, we're only going to get 2 copies of it. But if the count is 1, then we're only going to get 1 copy of it. We're going to take the minimum of these 2 values, and that's how many times we're going to iterate through this. And for every iteration, we're going to take the value at the right index and put it in the left position. And don't forget to increment the left pointer every time we do that. Now, regardless of how many times we do this, we know the right pointer is going to end at the ending of the streak, and we want to increment it at least 1 more time to get to the beginning of the next streak on the next iteration of the outer loop. After that's done, we will have the left pointer will be in the position that we need to return for reasons that we talked about earlier. So all we have to do is return the left pointer. Now let's run this to make sure that it works. And as you can see, yes, it does. It's pretty efficient, though Leetcode is random with the run times. If you found this helpful, please like and subscribe. If you're preparing for coding interviews, check out neetcode.io. It has a ton of free resources to help you prepare. Thanks for watching, and hopefully I'll see you pretty soon.